Welcome, leaders and innovators. Today we explore the true steering wheel of generative AI, prompt engineering. We will uncover how the way we instruct AI directly dictates the business value we extract from it. Let's get started. Let's start with the absolute foundation. What is prompt engineering? Simply put, a prompt is the input text or instruction that guides a generative AI model to produce a specific output. Generative AI represents a paradigm shift. We are no longer programming with rigid code. Instead, we are using natural language to instruct a reasoning engine. Why is this important? Because prompt engineering is the vital process of creating and refining these instructions. It is not merely a technical exercise, it is how we translate human intent into actionable machine output. The deep dive here is understanding that the model relies entirely on your prompt to determine the structure, tone, and accuracy of its response. Look at this left-to-right flow to visualize the concept. It begins on the left with human intent. This intent must be translated through prompt engineering, which acts as the crucial bridge. By crafting a structured natural language instruction, we feed the generative AI model node. The model then processes this instruction to generate a targeted business output. If the prompt engineering node is weak or vague, the final output will be compromised. This diagram shows that your prompt is the steering wheel for the entire AI ecosystem. Why does prompt engineering matter so profoundly to your organization? The impact is massive. Generative AI models are incredibly powerful, but they do not inherently know your business intent. They predict patterns. If you provide a poorly written prompt, the AI might produce irrelevant results, omit critical context, and ultimately waste your team's time as they struggle to refine the output. Conversely, when your organization invests in prompt literacy, you transform AI into a massive productivity enabler. How? Well-crafted prompts deliver outputs that align perfectly with business goals on the first try, accelerating workflows. The deep dive here is risk reduction. Specific, clear prompts drastically minimize the model's chance of misinterpreting a task, shielding your business from acting on inaccurate information. This decision tree perfectly illustrates the business impact of prompt quality. At the top, every AI interaction passes through the prompt quality gate. Follow the left path. A vague or poor prompt inevitably leads to misinterpretation by the model, which cascades down into wasted time and revisions. Now follow the right path. A clear, engineered prompt results in aligned output. This successful output branches into two massive business benefits: accelerated workflows and reduced operational risk. This visual proves that prompt engineering is not just a user feature, it is a critical efficiency control. Now, let's explore the anatomy of a highly effective prompt. How do we build one? At a basic level, every prompt requires two parts: the instruction, which tells the model what to do, and the context, which provides the background information. Why is this structure necessary? Because without boundaries, the AI will guess. To achieve optimal results, you must include four key elements: a clear goal, specific context, supporting data or sources, and clear formatting expectations. For example, don't just say, summarize this email. Say, summarize the customer feedback in this email into 3 bullet points for a marketing meeting. The deep dive insight here is framing. It is fundamentally more effective to tell the AI exactly what you want it to do, rather than giving it a list of what not to do. Let's break down this structural map. At the center is our effective prompt. It is supported by 4 essential pillars. First, goal, where you must be highly specific about the task, driving clear intent. Next is context, which provides the necessary background to ensure relevance. The third pillar is data, which supplies the raw information to guarantee accuracy. Finally, we have format, where setting structural expectations ensures the final output's usability. If you train your workforce to include these 4 nodes in every interaction, your AI ROI will skyrocket. Prompt engineering is a shared responsibility, but it looks very different depending on who is doing it. For business users, the focus is prompt literacy, crafting clear, contextual instructions for everyday tasks like drafting emails or reports. But how do we scale this? That brings us to developers. Developers take prompt engineering to a deeper, systemic level. Why? Because enterprise applications need standardization. Developers create structural prompt templates that can be reused across the organization to reduce variability. They also use advanced techniques like few-shot learning, where they provide the AI with a few examples within the prompt to teach it the desired output logic without retraining the model. For our deep dive, developers automate prompt generation dynamically using real-time data, ensuring reliable outputs at scale without requiring users to write manual prompts every time. This flow visually separates the two distinct personas of prompt engineering. From the source node, we branch to business users on the top and developers on the bottom. The business user path leads to ad hoc daily tasks, relying heavily on clarity and context. The developer path, however, drops down to enterprise scale. This splits further into advanced methodologies, templates, and few-shot learning to standardize responses and dynamic automation to trigger AI behind the scenes. Recognizing this dual approach is critical for leaders deploying AI across both frontline staff and IT architecture. Now let's talk about the economics of prompting. Every prompt you run consumes compute resources, which means it impacts both cost and performance. The basics are simple: the larger the input data, and the longer the generated response, the higher the cost and latency. Why does this matter? Unoptimized, verbose prompts waste money and frustrate users with slow wait times. How do we fix this? By applying strict constraints. For example, explicitly telling the AI to summarize in 50 words limits the output length, which is the single largest cost factor. Furthermore, avoid redundant instructions that confuse the model. The deep dive here is pre-processing. Before feeding a massive email chain or document into a prompt, clean the data. Strip out HTML tags, signatures, and boilerplate text. This drastically reduces your input tokens and speeds up the AI. Look at this optimization funnel. We start with heavy raw data and documents at the top. The first critical intervention is to pre-process and clean data, stripping out noise like HTML to reduce the input payload. Next, we apply output constraints, like limiting word counts, to control the generation phase. Only then do we execute the optimized prompt. The final result: lower token cost and latency. This diagram highlights that prompt engineering isn't just about getting the right answer, it is a financial and architectural necessity to run AI efficiently. A critical aspect of prompt engineering is ensuring accuracy. This is achieved through grounding and RAG, or retrieval-augmented generation. What is grounding? It means anchoring your prompt's instructions to your trusted enterprise data. Why is this vital? Because generative models are predictive engines. If you don't give them facts, they may invent or hallucinate information. How do we apply this in prompt engineering? We design prompts that dynamically connect to internal databases like Microsoft Dataverse, SharePoint, or uploaded files. The deep dive: within Prompt Builder, you can insert data references and apply filters directly in the prompt. For example, the prompt can automatically retrieve only high-risk accounts from your CRM, feed that verified context to the language model, and guarantee a factual, relevant response. This flowchart demystifies the RAG process within prompting. The user prompt enters the system, but notice it does not go straight to the AI. Instead, it hits the data retrieval RAG node. This node queries your secure Dataverse or SharePoint databases. The databases return verified context, which is injected directly into the prompt instructions. Only then is this enriched package sent to the language model. The output is a grounded and accurate response. This visual proves that prompt engineering combined with data retrieval is the ultimate defense against AI hallucinations. As we scale prompt engineering, we must address security. Slide 7 focuses on defending the prompt against adversarial attacks. What is a prompt injection attack? It occurs when a bad actor hides malicious instructions inside a document or email that a user asks the AI to process, tricking the model into bypassing its safety rules. Why is this dangerous? A hijacked prompt can generate inappropriate content or execute unauthorized actions, severely harming your company's reputation. How do we stop this? Microsoft utilizes prompt shields and content safety filters to analyze inputs and block these attacks before the model even executes them. However, the deep dive security practice is human in the loop. No matter how good your prompt is, consequential AI outputs should always require human oversight and validation before an automated action is finalized. Let's trace the security architecture of a prompt execution. External data or input enters the pipeline and immediately hits the red decision node, the prompt shield and safety filter. If a malicious injection is detected, the path branches left to instantly block and flag the request. If the input is deemed safe, it proceeds to execute the engineered prompt. But notice the green node before the end: human review and oversight. This human-in-the-loop ensures that the AI's logic is validated before resulting in a safe business action. This workflow is non-negotiable for enterprise AI. Let's tie this all together with a highly practical real-world use case: automating audits. Imagine a purchasing manager who must audit an Excel file of thousands of transactions against a PDF listing high-risk vendors. Doing this manually takes hours and is error-prone. How do we solve this? We create a highly engineered prompt with the code interpreter feature turned on. We instruct the prompt to ingest both the Excel and the PDF files, cross-reference the vendor names, and identify any transactions over $10,000 missing a purchase order. The deep dive here is the output. We don't just want text. We engineer the prompt to output structured JSON data or even a pre-formatted Word document. This allows the output to flow seamlessly into a Power Automate workflow that emails the final audit report directly to the compliance team. This is the ultimate power of prompt engineering. This sequence diagram illustrates the end-to-end automation made possible by advanced prompt engineering. It starts when data both the Excel and PDF files is uploaded to our engineered prompt. Because we enabled the code interpreter, the prompt autonomously cross-references the files and flags anomalies. It then pushes the result to the structured output phase, generating clean JSON or a formatted document. This structured data natively triggers a Power Automate flow, which handles the final mile, delivering the insights to the compliance team. This proves that a well-engineered prompt is actually a powerful software function.